Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve a hyperbola problem. As per the problem, identify the conic and find its foci and vertices. We are given the equation y squared plus 2y equals 4x squared plus 3. We have to identify the conic for this equation and then find its foci and vertices. Let's start by analyzing the given equation. This equation has variables x and y, and the square is on both x and y. Therefore, this equation does not represent a parabola. In a parabola equation, the square is either on x or y, not both of them. Next, we should move the x squared term to the left side of the equation because we want all x and y terms on one side of the equation. To do further analysis, I get y squared plus 2y minus 4x squared equals 3. Now we should analyze the coefficients of y square and x square terms. The coefficient of y square is positive 1. There is an invisible 1 with y square. The coefficient of x square is negative 4. Since one coefficient is positive, the other coefficient is negative. That means this equation represents a hyperbola. For an ellipse, both x square and y square terms have the same sign, and for a circle, both x square and y square terms have the same sign and the same coefficient. This is an important concept we need to understand and memorize. Now we can find the foci and vertices of this hyperbola. We should write the equation of this hyperbola in standard form. We have to use complete the square method for y. For x, we do not need to use complete the square method because there is only x square term in this equation. Let's start by analyzing the y terms. For y terms, we have to use complete the square. The coefficient of y square is 1, so we do not need to do any common factoring. The coefficient of the y term is 2. We divide 2 by 2, which is equal to 1. So we should add and subtract 1 square to the y terms. So I get y square plus 2y plus 1 square minus 1 square. For the x term, we can write x square as x minus 0 square. Next, we can combine y square, 2y and 1 square and write it as a perfect square term. So in parentheses, we write the variable first, which is y, and then we write the term that we squared, which is plus 1, close the parentheses and put a square outside the parentheses. Minus 1 square is just equal to negative 1. Next, we should add 1 to both sides to combine the number terms negative 1 and 3 on the right side of the equation. The equation of a hyperbola in standard form has 1 on the right side of the equation. We can change 4 to 1 by dividing each term in this equation by 4. So the 4's with the x cancel each other out and 4's on the right side cancel each other out, and we are left with y plus 1 square over 4 minus x minus 0 square over 1 equals 1. This is the equation of the hyperbola in standard form. As we can see in this equation, the x part of the equation has a negative sign in front of it. The coefficient of the x part is negative. That means in this hyperbola, the branches are above and below each other. The general equation of a hyperbola in standard form, whose branches are above and below each other, is y minus k square over a square minus x minus h square over b square equals 1. We can compare our equation with this general equation to find the values of h, k, a square and b square. As per the comparison, k is equal to -1 because in our equation we have y plus 1 and in the general equation we have y minus k. The h value is equal to 0, a square is equal to 4, so the value of a is equal to 2. We get it by applying square root to both sides, and b square is equal to 1, therefore b is equal to 1. Now we can use all of this information to find the foci and vertices of this hyperbola. Let's start with foci. The setup for foci of a hyperbola whose branches are above and below each other is h, k plus minus c. We can find the value of c from the equation a square plus b square equals c square. We can sub in the values. A square is 4, b square is 1. We can apply square root to both sides. I get c equals square root 5. We can use this value of c to find the foci of the hyperbola. The foci are h, k plus minus c. We can sub in the values. H is 0, k is -1. So the two foci are 0, -1 plus square root 5 and 0, -1 minus square root 5. Next, we can find the vertices of this hyperbola. The setup for vertices is h, k plus minus a. We can sub in the values. H is 0, k is -1 and a is 2. So the two vertices are 0, -1 plus 2 and 0, -1 minus 2. -1 plus 2 is equal to 1. -1 minus 2 is equal to -3. So the vertices are 0, 1 and 0, -3. These are the two vertices of this hyperbola. So these are the steps you have to keep in mind to solve this problem. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.